Hey everyone, Ronak from Trainy here, and today I'll be walking you through a couple of the features of Trainy's Konduktor platform. Now, for a brief introduction, Konduktor is a platform for GPU cluster management and AI workload submission. So we let you easily scale out multi-node jobs, queue them, assign priorities and quotas, and more. And on top of all that, you get this pretty little dashboard here that shows you all of the statistics you could care about your GPU cluster. So let's jump right in. Now, first of all, we can actually set up an interactive session with Trainy's Konduktor platform where you can just SSH into nodes and do that for dev work. Really simple to use, but not going to go over that in too much depth today just because it's a little bit out of scope. So let's get right into it with the training job. First of all, we have you submit jobs with this YAML file, and one of the important things to define is your resources. So first of all, we have our Docker image ID, so that's super important. Ensure that you have PyTorch, all of the right CUDA drivers, and everything installed with correct dependencies. We specify our accelerators. Now in this cluster, I'll be using 4x T4 nodes, so 4 T4 GPUs, and 2 of these nodes that I have access to. One of the important things here to note is the labels. So first one here is a user queue. Now this is set up by your admin, but this essentially allows multiple ML teams to all access the same cluster with varying quotas. We also have a priority class, but I'll be going into this a little bit later. So we can specify the number of nodes we launch this job to, just like this. Very easy to scale out multi-node. And we also have this setup section. Now, setup and run sections both are just bash scripts that you can include, and they allow you to set up your environment and then run the workload. So in setup, you could see that we're pulling the repository with the code, grabbing our data, and getting that set up in the right directories. In our run, we can see that we are essentially going into our training code and launching the training job. And this should look pretty familiar as your standard PyTorch distributed launch. So let's get this job going. Very simple to do, just Sky Jobs launch. Let's name it ResNet Training and include this training YAML file that I've just set up above. Nice, so it looks like the job has been submitted. So let's take a look at our dashboard and make sure everything checks out. Nice, so we can see there's one active workload, allocated all 8 GPUs on the cluster, so we know multi-node is working. And yeah, we can see ResNet Training 1 active. So of course it'll take a little bit before the training workload actually starts, but in the meantime, let's queue up a couple more of these jobs. Cool. So we can see that we've now submitted 3 jobs to the cluster, and let's take a look. Nice, so jobs 2 and 3 are pending, and job 1 is still active. We can see that we are starting to work these GPUs slowly but surely, and not too much memory use, but this is a pretty small ResNet model, so we could have upped the batch size probably, but nothing to worry about. Yeah, looks good. So next, let's take a look at this priority feature. Now, one of the cool things that we have in our scheduler is preemption. So that means if you launch a high priority job, it'll actually be able to take the resources away from these lower priority jobs that we've already launched. So let's give that a try. I've just edited the existing YAML, so let's launch this new high priority workload. Cool, so it looks like the high priority job has launched. Let's take a look at our dashboard just to see how things are going. Nice. So as you can see, it used to be ResNet Training 1. We have now preempted that with our latest workload, ResNet Training 4. And ResNet Training 1 is back happily on the queue, ready to be run the moment this high priority workload is complete. So that's great. Everything seems to be working fine. Now, one of the most important other pieces about these large-scale training workloads is managing node health. These GPUs fail quite often, and if it happens during a training workload, it normally requires a manual restart. Luckily, with the Konduktor platform, when something goes wrong, we can isolate which GPU this issue occurred with, taint that GPU so that is removed from the healthy pool, and resume your training workloads on the healthy nodes. So let's give that a look. So there we go. The machine now thinks that a demessage error has been hit on one of its nodes. And right here, so yeah, we could see that GPU memory has dropped because we've paused the workload. And we could see that the demessage error has shown up. Great, nice. So this was a little overview of the couple of the features we have. We also offer, our platform can also handle serving endpoints. So we can actually set up a load balancer with multiple replicas to make sure your LLM inference servers get good latency in production. But yeah, this was a quick overview of the features we have in the Trainy's Konduktor platform. If you have any questions or would like to see more of this, yeah, just ping me and reach out either on LinkedIn or ronak@trainy.ai. Thank you so much for watching and I hope you have a great day.